Sir, you're muted.
Wow, wow. Sorry, I don't know. All right. So now, um, metal extraction, metal extraction, right? So I said that some metals can actually be extracted by thermal reduction. Okay, when you react the ore of those metals with carbon, when you react the ore of those metals with carbon, then what you will get will be the pure form of that metal, right? But it is not all metals that can be obtained using this method, using thermal reduction method. And the reason is because those metals are more reactive, okay? Those metals are more reactive than carbon. So you can extract them or you can make them using the thermal reduction method, right? Similarly, another reason is because some of those metals react with carbon in the process, like aluminum, we form aluminum carbide. If calcium react with carbon, it will give calcium carbide, right? So you can't, use thermal reaction to obtain those metals that are more reactive than carbon or those metals that would react with carbon by that process. Or the process you can easily use in extracting those is by electrolysis, right? So electrolysis is used to extract metals that cannot be extracted by heating with carbon, okay? That cannot be extracted by heating with carbon. So metals produced this way are expensive, okay? Metals that are produced by the method of electrolysis are very expensive because of the high cost of energy for heating. You will need to heat, very well. You will heat the ore where the metal that you want to extract is combined, right? So when you heat them, then you can now carry out the process of electrolysis. Now we're going to see how we extract aluminium, okay? How do we extract aluminium, right? By electrolysis. Now you have this outline. So the main ore of aluminium is bauxite, and it contains aluminium oxide, Al2O3. Now, this is the aluminium we, we want to extract. We want to separate this aluminium from oxygen and all other impurities that could be present, right? Now, so the main ore of aluminium is this bauxite, that is Al2O3, which has a very high melting point of 2072 degrees Celsius, that is 2072 degrees Celsius, right? Now, which means you have to heat the ore to this temperature and above for it to melt. That is its melting point. So the cost of the thermal energy to melt aluminum oxide is very high. The cost is very high and is very expensive. So hence, instead of heating this aluminum oxide directly, you can react it or mix it with cryolite. So why are we combining, or why are we reacting cryolite with bauxite? The reason is to reduce the melting point of the bauxite, okay? Instead of heating to a very high temperature that will consume high energy, and you have to first react with it, but you have to combine it with cryolite. Cryolite, the mixture of cryolite and bauxite will melt at 950 degrees Celsius instead of 2072 degrees Celsius. All right. So when you react bauxite with cryolite, then the melting point will be reduced and the cost of energy will also be reduced. Is that clear?
Yes, sir.
Good. So in the process, the electrode that is used in the electrolytic setup is graphite, the carbon form. You know, we learned in the past that carbon exists in different forms. We have the diamonds, we have soot, we have the graphenes, fullerenes, right? They are, forms of carbon. But now, what they use as electrode in the electrolysis of aluminum is the graphite, meaning both the cathode and the anode in the electrolytic setup is graphite. So aluminum ion are attracted to the negative electrode, okay? So meaning during the electrolysis, the aluminum will migrate to the cathode, right? The aluminum will migrate to the cathode, right, which is the negative electrode. Aluminum ion is the cation. So where they gain electrons, okay, and form aluminum metal, okay? Now, this is the cathode, the red line. This is whole process. The process by which we extract aluminum, okay, is known as the Hall process. Now we have this setup, electrolytic setup. So the red panel there, that's the cathode. That is where the aluminum will be formed. Okay. So this is aluminum. It's going to gain 3 electrons to become aluminum solid. Then it will be, you will get your aluminum through this channel. This is the molten aluminum. Right. So this is the cathode, and aluminum will be produced there. We've seen by gaining electrons. Now, what will happen to the oxide? We said this is where we want to extract the aluminum from. Now, we need to know what will happen to the oxide in the bauxite. Now, the oxide, that is O2 minus, are attracted to the positive electrode. Okay, they are attracted to the positive electrode where they lose electrons to form oxygen. Okay, so they lose electron to form oxygen, and you can see that here. This is the oxygen, oxide ion is losing 4 electrons to become, oxygen, oxygen gas. But meanwhile, something needs to be noted. The oxygen reacts with the graphite anode. Yes, the graphite is made up of carbon, and the oxygen will react with it. This is the anode, the purple panel. So the oxygen that is produced there will react with the carbon to form carbon dioxide. And when carbon dioxide forms, because the graphite will burn, the oxygen react with graphite anode, and so the anode burns to produce carbon dioxide. This means that the anode has to be replaced regularly. Okay, so you have to keep replacing the anode regularly and regularly, and this is the electrolytic setup. Okay, that's the anode, red line, the cathode. Okay, oxygen will be produced here at the anode, and it reacts with carbon and make the electrode to burn. And when it burns, what's going to happen? You have to keep replacing it. You have to keep replacing it. The aluminum we want to manufacture will be produced at the cathode, will be produced at the cathode, okay? The aluminum will be produced at the cathode, and we have it there. Is this clear?
Yes, sir.
All right, good. So you can write this now, and I'm going to ask you questions immediately after you finish writing.
Can you scroll down, sir? Can you scroll down, sir? Can you scroll down, sir?
You will draw the diagram and label appropriately.
I'm done, sir.
Are you done drawing this?
Yes, sir.
All right. So based on that, can you do these questions?
Can you scroll down, sir? I've sent it to you, sir.
All right, good. Impressive. So, there are two questions with subs. The first question says, give two reasons why some metals cannot be extracted by heating with carbon. So, what do you put on there? I'm going to check the mail now. But meanwhile, tell me what you put on there. What was your response to the question, to the first question? Can you speak louder, please?
There are more reactive than carbon, so they can be displaced.
Okay, that's one.
Another one could be that electrolysis is too expensive, so you're using it with um metals that can be reduced isn't worth the money.
Hmm, good. All right. Next question says, name two metals other than aluminum that can be extracted by electrolysis. What do you put on?
Potassium and sodium.
Good, good. Then the next say, give two reasons why the energy cost of extracting metals by electrolysis is so high. Why?
Because melting the metals um takes a lot of energy, which is expensive, and the electricity has to be high, and that's expensive as well.
Okay, good. Question two. This question is about the electrolysis of aluminum by electrolysis. Identify the compound from which aluminum is extracted. What compound is that?
A 2O3, Al2O3.
Al2O3.
But in my answer, I thought they meant the O name, so I put both sides.
Okay, that's still fine. That's still fine. All right, the next one says, why is the compound mixed with cryolite?
To lower its melting temperature.
Good. To lower its melting temperature. And the next one says, what happened? Okay, what happens at the positive electrodes?
Reduction.
Yes, we know reduction will occur at the cathode. So the positive electrode oxidation normally occur there. So that is not actually correct. And we are not we don't want you to respond to either reduction or oxidation. Well, what will be produced? Yes, fine. Um Oxidation will occur here, and there will be, you know, loss of electron, and the oxygen produced will react with the graphite electrode, which is carbon, and it's going to burn it. So we need to keep. Okay, that's what happened there. And what happened at the negative electrode?
I put oxidation there.
Oxidation. Okay, if you put oxidation there, the negative electrode, there the, you know, which is the cathode, there the aluminum will be deposited. Sorry. So aluminum will be deposited, right? And that is where you get your molten aluminum. Okay, so that is what we are expected to tell us, because the question is about extraction of aluminum by electrolysis. Okay, and the next one says, what are the electrode made of?
Carbon or graphite.
Yeah, graphite. They are also form of carbon. Okay, why does the positive electrode has to be replaced regularly? Mentioned.
Because it will combust with oxygen.
Okay, good. All right. I think that is it for today. That is it for today. So we're going to stop here, God's grace. So we continue in our next lesson. But before then, would you like to ask any question?
No, sir.
All right. So in the absence of questions, do have a lovely night rest. Bye.
Bye.